Welcome back to SST June. Students, as you know that nowadays we are studying our chapter 4, that is distribution of oceans and the continents. So in that series, in our today's third video, today we will see few more topics, in which our today's first topic, that is plate tectonic. The plate tectonic, in this topic we will see the types of plate boundaries, that is divergent boundary, convergent boundary and the transform boundary. Again you can see in this picture, that is divergent boundary, that is convergent boundary and that is the transform boundary. Our next topic is rates of plate movement and force for the plate movement. Then after that we will see our today's next or the last topic of the chapter, that is the movement of the Indian plate. That in this one topic we will see how the Indian subcontinent formed, what were the reason behind that, how the plate tectonics were there, due to that the Indian subcontinent was formed. So let's see that what is plate tectonics. Plate tectonics is the theory that Earth's outer shell is divided into several plates that glide over the mantle, the rocky inner layer above the core. The theory of plate tectonics was introduced by McKenzie, Parker and Morgan in 1967. The plates act like a hard and rigid shell compared to Earth's mantle. This strong outer layer is called the lithosphere. It is a massive irregular-shaped slab of solid rock. Plates move horizontally over the asthenosphere. Average thickness is 100 km of oceanic part and 200 km of continental part, as you can see in this given picture. Pacific plate is largest oceanic plate, whereas Eurasian plate is the largest continental plate. So here we can say a plate may be referred to as the continental plate or oceanic plate, depending on which of the two occupy a larger portion of the plate. The theory of plate tectonics proposes that the Earth's lithosphere is divided into 7 major and some minor plates. Young fold mountain ridges, trenches and for faults surrounded these major plates. Here, as you can see in this given picture, the major plates of the world are South American plate, number 2, Antarctica and the surrounding oceanic plate, number 3, North American plate, number 4, India, Australia, New Zealand plate, number 5, Pacific plate, number 6, Eurasia and the adjacent oceanic plate, and the number 7 is Africa with the Eastern Atlantic floor plate. Here are some important minor plate too. These are Cocos plate, number 2 Arabian plate, number 3 Nazca plate, number 4 Philippine plate, number 5 Fuji plate, and the number 6 is Caroline plates. There are total 3 types of plate boundaries. As already I told you, number 1 is divergent boundary, number 2 convergent boundary, and number 3 is transform boundary. So one by one, first divergent boundary. What is divergent boundaries? In plate tectonics, a divergent boundary or divergent plate boundary, which is also known as a constructive boundary or an extensional boundary, is a linear feature that exists between two tectonic plates that are moving away from each other. These are also known as spreading sides. For example, mid-Atlantic ridge. If we will talk about the second type of plate boundary, that is convergent boundary. In plate tectonics, a convergent boundary, also known as a destructive plate boundary, is a region of active deformation where two or more tectonic plates or fragments of the lithosphere near the end of their life cycle. Here, crust is destroyed as one plate dives under another. Subduction zone is the location where sinking of a plate occurs. The convergence of plate can occur in three ways. First, between an oceanic and a continental plate. Number 2, between two oceanic plates. And the number 3, between two continental plates. The third type of plate boundaries is transform boundaries. A transform fault or transform boundary, which is also known as a conservative plate boundary, since these faults neither create nor destroy lithosphere. It is a type of fault whose relative motion is predominantly horizontal. In either a sinistral means left lateral or dextral means right lateral direction. Also, we can say the rotation of the earth has its effect on the separated blocks of the plate portions. So, here is a question, that is, how do you think the rate of plate movement is determined? So, let's move to our next topic of this major topic, that is rates of plate movement. The rates of plate movement are determined with the help of the stripes of normal and reverse magnetic field that parallel the mid-oceanic ridge. As already I told you in our second video, the Arctic ridge has the slowest rate. It is 2.5 cm per year, while the East Pacific rise near Easter Island. In the South Pacific, about 3,400 km west of Chile, has the fastest rate. It is 15 cm per year of the plate movements. Here, some sources state that in the North Atlantic, the rate of movement is only about 1 centimeter, about 0.4 per year, while in the Pacific it amounts to more than 4 centimeter. If we will see the average annual plate rates, it is generally travels from 5 to 10 centimeter per year. So question is that what are the causes of plate movement? Means, is there any type of force which is behind the plate movement? So let's see the force for the plate movement. For much of the last quarter century, the leading theory of the driving force behind tectonic plate motions is the large-scale convection currents in the upper mantle, which can be transmitted through the asthenosphere. The surface of the earth is dynamic and the interior is always mobile, means it is not stable. Beneath the lithosphere, there is always movement of magma horizontally, which already you have studied in your third chapter. So here we can see the slow movement of hot, softened mantle that lies below the rigid plates is the driving force behind the plate movement. So student, it was the plate tectonic theory in which you have studied the tectonic plate is a massive irregularly shaped slab of solid rock, generally composed of both oceanic and continental lithosphere, in which you have studied about the theory of plate tectonic and the boundaries of plates. You have also studied the rates and the forces behind the plate movement. So now let's move to our next major topic of today's. It is movement of the Indian plate. In our last video, I have explained you about the supercontinent which was known as Pangaea. Later, it was broken up and divided into two major continents which were known as the Laurasia and the Gondwana. So, the Indian plate is originally a part of the ancient continent of Gondwana. India broke away from the other fragments of Gondwana 100 million years ago and began moving north, as you can see in this picture. The Indian tectonic plate is located in the northeast hemisphere. It is bounded by four major tectonic plates. That is, north of the Indian plate is the Eurasian plate. To the southeast, the Australian plate. To the southwest, the African plate, and to the west, the Arabian plate. The Indian plate includes peninsular India and the continental portions of Australia. The subduction zone along the Himalayas form the northern plate boundary in the form of continent, which is known as continent convergence. In the east, it extends through Rakinuma mountains of Myanmar towards the Iceland arc along the Java Trench. If we will see the movement of Indian plate direction wise, at the eastern margin is spreading side and western margin extends along Kirthar mountains, and the boundary between India and Antarctica is known as divergent boundary. In the ancient time, India was a large island situated off the Australian coast in a vast ocean. The Tethys Sea separated it from the Asian continent till about 225 million years ago. India is supposed to have started a northward journey about 200 million years ago, at the time when Pangea broke. India collided with Asia about 40 or 50 million years, which resulted into the rapid sight of Himalayas. Yes, you are right. At the place of Cbse, now Himalayan mountain range is there, and it was just because of the movement of the plates. As you can see in this given picture, depicts the movement of Indian plate over the geological periods. The Indian subcontinental was located at 50 degrees south latitude about 140 million years before the present. The formation of Deccan Traps approximately 60 million years ago was one of the major events during the movement of Indian plate. The formation of Himalayas started at around 40 million years ago, and the process is still continuing, and Himalayas is still gaining height. Students, I know that still many questions are moving in your mind. So, to resolve these questions, I am giving you some interesting fact about the movement of the Indian plate. So, might be the first question is, in which way is the Indian plate moving? So, for that question, the answer is that the northeast. The Indian plate is currently moving to northeast at 5 centimeters, means 2.0 inch per year, while the Eurasian plate is moving north at only 2 centimeters per year. This is causing the Eurasian plate to deform and the Indian plate to compress at a rate of 4 millimeters per year. The next interesting fact is about the evidence of plate movements. Evidence of plate tectonics. Modern continents hold close to their distant past. Evidence from fossils, glaciers, and complementary coastlines helps reveal how the plates once fit together. It is look like a jigsaw puzzle, which already I told you in first video in our topic, the Pangea. Fossils tell us when and where plants and animals once existed. So, for the conclusion of today's topic, we can say the theory of plate tectonics proposed that the Earth's lithosphere is divided into plates, and these plates have been moving over the globe throughout the geological history of the Earth. So, students, here the chapter Distribution of Oceans and Continents is complete. To better understand this chapter, I am providing you the previous 2 links of this chapter. To know more about our Earth, keep watching SST June.